Okay, folks, I'm going to try to show you something about charging and discharging capacitors. Here's two capacitors. These are really nice, expensive capacitors. They are about $1 each. These things hold a whopping pile of charge. Then I just have my usual battery with a couple of clips hooked up to it. So if I put the battery on the bulb, there's my bulb lighting up. Now, let's put the battery and the bulb in line with the capacitor. So we charge the capacitor. So watch what happens. Hook. Notice how the bulb is getting dimmer and dimmer. I am charging the capacitor. As the capacitor fills up with charge, its voltage builds up and less current can flow through. A couple of people asked, well, shouldn't a capacitor just block the flow of current in the DC circuit? And the answer is yes, it will. And there it has. I've blocked the flow of current in the DC circuit. It just takes a while because the capacitor can hold so much charge. It takes a while to fill up. But as people have said, a couple people said in their questions, a capacitor has an insulator in the middle of it, so it should block the flow of current. And in fact, it does. Now the capacitor is full of charge. Okay, it's holding charge in there. Think of a capacitor as a wound-up spring. It's storing energy. Now, a couple people asked, how long will the capacitor hold the charge? The answer is indefinitely. Okay, if it's a good capacitor, it can hold charge indefinitely, which means that when you are dealing with capacitors in a work situation, you need to be careful because a capacitor could have been charged up a long time ago and still hold charge. So never go and just grab a capacitor because it could have charge on it and could shock you. It could have a lot of charge in it, so it's best not to take a screwdriver or something and stick it, because it could be like sticking a screwdriver across a 12-volt car battery. You could get sparks. Rather, you use a bulb or something like that so that it will discharge more slowly. So it's got charge stored in it. Now I'm going to hook this this bulb up to it. Here we go. Boom. See it light up? The capacitor is now powering the bulb, but the capacitor is unlike a battery, which can keep turning chemical energy into electrical energy. The capacitor just has stored electrical energy, so it unwinds like a spring. And so you can see that it's losing its oomph, okay, as it goes. It's running down. There we are. Now, let's do this with two bulbs in parallel. So hook this up like this, hook this up like this. With the bulbs in parallel, it should charge and discharge more rapidly. Oops, here we go. Go. Charge. And see, with more current flow, the capacitor fills up quicker. Now, discharge it. It will also discharge quicker. Oops. Oh, I shorted it out and discharged it too quickly. Sorry. Do this again. I shorted. It's very easy to cross-connect things right there, especially with these. Okay. Charger up again. And now we'll discharge it. there we go. If I take these two capacitors and put them in series in parallel, I'll see that the time changes. So I'm going to pause it for a minute.